Welcome back everyone to my channel Chemistry Made Simple for NEET. I am Dr. Radha Subramaniam with a PhD in Chemistry. So today we are going to revise the lesson equilibrium and I have divided into different parts. So today we will be learning part 1. So before I start with today's important concepts, I would like to share with you a few important tips for the preparation for NEET exam. So keep these tips in your mind when you are practicing for Chemistry NEET UG. First thing is, don't stop practicing. Practice is a must for NEET UG aspirants, and you should have proper study plan to practice enough questions before the actual exam. Make sure that you have room for breaks in between your study to refresh your mind, but don't let the breaks be too long. And secondly, attempt online mock tests. It will help you to access your weakness and work on them before the exam. After some mocks, the candidate will get to know the strengths and weakness, and then he or she can make changes accordingly. Then another important tip is to revise repeatedly. You must revise each chemistry chapter at least 3 times. Thorough revision is a very good strategy for acing the NEET exam. Some mistakes to avoid during the preparation is, always you have to be well prepared with both class 11 and 12 portions well ahead of the exams, and when the exams approach or just before 1 month of the exam, just quickly revise all the important concepts, topics and important MCQs, and make it a practice to do the mock test at the same time when the NEET exams would take place. Okay, so with that we will move on to the starting of the equilibrium. So here, what is in the equilibrium? First we will see what is the meaning of equilibrium. Chemical equilibria, it's important in numerous biological and environmental processes. So for example, equilibria which involves oxygen molecules and protein hemoglobin plays an important role in the transport and delivery of oxygen from our lungs to the muscles. And equilibrium can be established for both physical processes and chemical reactions. And when the reactions take place, suppose in a closed vessel at a particular temperature, the reactants react to give products, and the concentrations of the reactants keep on decreasing, because the reactants are participating in the reaction, means their concentration will keep on decreasing, while those of products will keep on increasing for some time, after which there won't be any change in the concentration of reactants or the products. So this stage of the system we call it dynamic equilibrium, and based on the extent to which the reactions proceed to reach the state of chemical equilibrium, we can classify this into 3 groups. Firstly, the reactions which proceed nearly to completion and only negligible concentrations of the reactants are left. Secondly, reactions in which only small amounts of products are formed and most of the reactants remain unchanged at the equilibrium stage. Thirdly, the reactions in which concentrations of the reactants and products are comparable when the system is in equilibrium. So equilibrium involving dissolution of solid or gases in liquids. So solid in liquids means when no more solute can be dissolved in the solution, it is called a saturated solution. That is sugar solution. Sugar is solid. Also the rate of dissolution of sugar will be equal to the rate of crystallization of the sugar. So the ratio of the radioactive molecules to the non-radioactive molecules in the solution will increase till it attain a constant value. Okay, now what are the general characteristics of equilibria involving physical process? We already saw that equilibria involves both physical and chemical process. So equilibrium is only possible in a closed system at a given temperature, and both the opposing process will happen at the same rate, and there is dynamic but a stable condition. So once the system reaches the equilibrium for a physical process, it is characterized by a constant value of one of the parameters at a given temperature, and the magnitude of such quantities at any stage shows the extent to which physical process has proceeded before it reaches the equilibrium. So read this part well before you proceed into the next topic. Okay, now here what does the value of K mean? You see, reactants will react to give the products, and this is a reversible reaction, means both forward reaction and backward reaction will take place. So there are two cases. First case, if K is greater than 1, the reaction is product favored, that is product will predominate at equilibrium. If K is less than 1, then the reactant favored reaction it will be, and the reactant will be predominate, reactant will predominate at equilibrium. Okay. Now what is heterogeneous equilibria? Equilibrium in a system having more than one phase, we call it heterogeneous equilibrium. For example, see the case of the water vapor and liquid water. If you take it in a closed container, then the equilibrium between these two is known as, or it can be taken as an example for heterogeneous equilibria. Okay, now here you can see three cases. Reactants react to give you products, movement towards equilibrium, and reactants and products are both at equilibrium. Then here movement towards equilibrium from this end. Okay, so firstly, if QC greater than Kc, net reactions will go from left to right. If QC is less than Kc, net reaction will go from right to left. If it is equal, then no net reaction will occur. You can see here QC reactants and Kc products. Okay, now next, calculating equilibrium concentrations. How do you calculate the equilibrium concentration? First of all, for this what you have got to do is always write the balanced chemical equation for the reaction, and then under the equation make the ICE table, that is initial concentration, the change in concentration of the ongoing equilibrium, ongoing to equilibrium, then equilibrium concentration. Then after that you have to substitute the equilibrium concentration into the equation and solve for x. It will be a sort of like quadratic equation or something, and you can solve for x. You know, predicting the direction of the reaction. How will you predict to which side or which direction the reaction is taking place? So equilibrium constant helps in predicting the direction to which the given reaction will proceed in any stage. For this we have to calculate the reaction quotient Q. So it is denoted with QC. What is QC? Reaction quotient with molar concentration. Then if reaction quotient is greater than Kc, then the reaction will proceed in the direction of the reactants, that is reverse reaction. If Qc is less than Kc, the reaction will proceed in the direction of the products, forward. You see reactants left side, forward reaction means it forms products, so that is a forward reaction. Okay, so these two cases you just remember. Now once the system reaches the equilibrium or the equilibrium is achieved, the amount of reactant and the product will be the same. So here the graph with time along the x-axis and concentration along the y-axis. Here the equilibrium is achieved. So you can see for NO2, here N2O4. So both has reached equilibrium here, as you can see in the figure. So it remains, see, a straight line from here, from the equilibrium position. Okay. Now how will you predict the extent of the reaction? So the magnitude of the equilibrium constant Kc and Kp, these two are directly proportional to the concentration of the products and inversely proportional to the concentration of the reactants. So if suppose K is very large, then the reaction will proceed nearly to completion. If K is very small, then the reaction will proceed only very rarely. So this is how we can predict the extent of the reaction. So you can see here, okay, proceeding to completion, both reactants or products present in the equilibrium. Here it proceeds very, if K is small, it rarely proceeds. Okay, now first I'll we missed out an introduction for the equilibrium state in our notes, whereas I've explained the introduction in the beginning itself. So when a liquid evaporates in a closed container, then the molecule which has got higher kinetic energy, they tend to escape from the liquid surface into the vapor phase. They strike the liquid surface and they are retained in the liquid phase. So because of that, it gives rise to constant vapor pressure, due to which an equilibrium in which the number of molecules leaving the liquid will be equal to the number of molecules returning to the liquid from the vapor state. Now we say that the system has reached an equilibrium state. Okay, equilibrium constant in a gaseous system. PV is equal to nRT, that is P is equal to nRT by V. See, P is the pressure in Pascal, N is the number of moles and volume in cubic meter, T is the temperature in Kelvin. So C is the concentration in mole per liter and P is in bar, then P is equal to CRT. R is 0.0831. bar liter per mole K. Now here you can see 3 cases. Now if it is less than delta G0 less than 0, then delta G0 by RT will be positive, and delta E raised to minus delta G0 by RT, if it is greater than 1, then it makes K greater than 1, which says that, or which denotes that a spontaneous reaction, or the reaction which proceeds in the forward direction to such an extent that the products are present predominantly. Suppose if this is greater than 0, then this will be negative, that is, if this is less than 1 here, it was greater than 1, this is less than 1, and K greater than 1 here, less than 1 here, which shows the non-spontaneous. Here it is spontaneous reaction, here it would be non-spontaneous reaction, or reaction which proceeds in the forward direction to a small degree, that only very minute quantity of the product will be formed, small amount of product is formed in such cases. Okay, then what of law of chemical equilibrium constant? So we know that for a reversible reaction, A plus B gives reversible arrow C plus D. So reactants and products are balanced, and so we can relate them by equilibrium equation. K is equal to C, write always the product side concentration on the numerator and reactant side in the denominator. Kc is called the equilibrium constant, and expression here, this is called the equilibrium constant expression. Very easy and simple this is. Now dynamic equilibrium. So you know, general case of equilibrium reaction, A plus B giving C plus D. When the time passes, accumulation of the product C plus D will happen, and depletion of lessening of the reactants A and B, and what happens because of this is leading to the decrease in the forward reaction and increase in the rate of the reaction. Finally, the two reactions occur at the same rate, and the system is said to be in equilibrium, or reaching an equilibrium. What happens, what is the effect of concentration change? So Le Chatelier's principle says that concentration stress of added reactant product, it is relieved by the net reaction in the direction which consumes or which uses up the added substance, and the concentration stress of a removed, or if you remove the reactant or product, it is adjusted or balanced by the reaction in the direction which replenishes the removed substance. So we can say that when the concentration of any reactant or product in a reaction at equilibrium is changed, composition of the equilibrium adjusts or changes itself to minimize the effect of those changes. Okay, now depicting equilibrium. In a system at equilibrium, both forward and reverse reaction are carried out. Because of that, we can write the equation in a double arrow, saying that both the reactions are taking place simultaneously. So the partial pressures of these two gases also will be equal. Now homogeneous equilibria. In an homogeneous system, the reactants and the products are in the same phase, that is solution phase, and so we can say that in the next reaction, and ions are equal. CH3COO C2H5 plus water, reversible arrow, CH3COOH plus C2H5OH aqueous, and iron 3 plus aqueous plus SCN minus gives FeCSCN 2 plus aqueous. Okay, now what are the factors affecting the equilibria according to Le Chatelier's principle, which says that a change in any one of the factors which determine the equilibrium conditions of a system will cause the system to adjust itself so as to nullify the changes brought out by the factors. Okay, now at a given temperature, the product of the concentration of the reactants products raised to the respective stoichiometric coefficient in a balanced chemical equation divided by product of the concentration and reactants raised to the individual stoichiometric coefficients as a constant value. So we call it a law of chemical equilibrium. So this is a general reaction, we can write like A plus B gives C plus D. So equilibrium constant for the reverse reaction is the inverse equilibrium constant of the forward reaction, or the reaction in the forward direction. Okay, gases and liquids and Henry's law. So set in equilibrium between the molecules of the gaseous state and liquid state. Suppose carbon dioxide is in the gaseous state and carbon dioxide in solution. So what does Henry's law say? It says that the mass of a gas dissolved in a given mass of a solvent at any temperature will be proportional to the pressure of the gas above the solvent. The amount decreases with the increase in temperature. Okay, so here we can say that first we have to calculate equilibrium concentration and find out the value of x, and check the results by substituting them into the equilibrium equation. We are having more parts of this lesson to come, and once we finish off this topic, you will be finding it easy to learn. So as always, I say please do share, like and subscribe to my channel, share it with your friends, and don't forget to press the bell icon so that as soon as I post new videos you will get the notifications immediately. With that, we are coming to a conclusion of this session, and thanks for watching my video.